Good afternoon.
Good afternoon.
So is it just you today, Joran and Mogyan?
No,
I'm here.
Hannah's coming.
All right. All right, so it looks like we've got Winslow and we've got St. John. So everybody feeling okay today? Anybody sleepy like I am?
Yes, sir.
A little bit.
Yep.
A little bit sleepy. So anyway, I just cannot, I'm having a hard time getting energy today. And they're just finalizing the summer school schedule. And for some reason I agreed to teach on Mondays and Wednesdays for 11 hours on those days. That is just insane because it takes it takes way more energy to teach than, to just, anyway. I don't know what I'm thinking. But the thing I love about summer school, if any of you are, as we get closer to it, we'll talk more about Calc 3. But the thing I love about summer school at MPC is they just do it Mondays and Wednesdays. And so, at least my classes are. So every weekend is a 4-day weekend and you feel like you can go and do stuff. And so it feels like summer. And I really like that. So I can work hard if I can play hard a little bit too. So anyway. Well, does anyone have any plans for this weekend?
We have a robotics competition in the valley.
Okay. So where is that at?
It's at Canyon View High School. It's kind of out in the middle of nowhere next to the valley.
Okay.
Way out there.
Well, that's pretty cool. Anyway, it's because I'm going to be in Mesa tomorrow. And I was just wondering, I thought, well, if you're going to be in Mesa, I could come watch
No,
a little bit.
we're on the other side of the valley, so.
Okay, that's all right. Anybody else do anything fun? Any big plans?
There's wrestling regionals this weekend.
Okay, all right. Well, that sounds good. So where is that held?
For us, it's in Winslow.
Oh, wow. Okay. All right. Well, that should be very fun. So, yeah, I have a friend that she's involved in wrestling with, she's like a coach for the girls or whatever. Anyway, wrestling season starts and it's like, and I don't know if this is the way with you, but it just seems like no social life at all. I don't know why. Anyway, it seems like basketball players do a little bit more, but I guess with wrestling, you're so worried about meeting weight and everything like that. I don't know. Am I wrong? Are wrestlers like tighten it up more than anybody?
I don't know. I mean, I feel like yes, but I don't know if it's just because we're all tired all the time or what.
Well, that might be true. Anyway, so I remember that I saw this thing and it was a meme where it was a calculus student that was also I know it was an athlete, so it was either a wrestler or basketball player. I can't remember which, but it came about mid-February, about this time, and so the meme was, "I sure could use a girlfriend for a change." Anyway,
I don't know what you mean by.
So anyway, I got a kick out of that just because you guys are the busiest ones in the whole school, so. Well, anyway, let's go ahead and get started. So our goal today is we want to finish 7-6, and I don't know if we'll be able to start on 7-7. I don't know. We'll just have to see how it goes. Now, really, this screen here actually reminds me that a lot of this, the next two sections, 7.6 and 7.7, it's a lot about formulas. Okay? Now, at least take some comfort in the fact that I'm not making you memorize all these formulas. Okay? But what I am going to have you do is practice with them. So get comfortable using the formulas. But in the next two sections, there are loads of formulas. Okay? So I'll just kind of warn you about that up front. Okay, so this one is the derivative of the arc sine. Okay? So what you do on these is typically, I do these with u substitution. And so usually the u is whatever the argument is. So the inverse sine of u, the derivative, is 1 over the square root of 1 minus u squared. And then it's kind of like the chain rule. You have to multiply by du dx. You have to multiply by the derivative of u. All right? So if I'm doing this, then the way I do it is I will first say, whatever the argument is, let u be that. And then the derivative, the du dx, so the derivative of x squared is 2x. All right, so then I look at the formula. Okay, so here's the formula over here. And so now when I do my u substitution, then in the numerator I'm going to have the derivative, so 2x over, and then the square root of 1 minus u squared. So that would be 1 minus x squared squared. And then x squared squared is just going to be x to the fourth, and that's your answer. Okay, so there's nothing tricky about it. And this one, the u, you probably could do it without doing a u substitution, but sometimes the u does get a little tricky. So at least when you're first starting out, I would recommend it, but if you can do it without it, that's up to you. All right, so go ahead and try practice 4. All right, so Jordan, when you've got it.
All right, I got 3x squared divided by the square root of 1 minus x to the 6th power.
That's it. Very good. All right, any questions on that?
Can you just scroll up a little bit, please?
Sure. Actually, this should be here. This is the formula.
Okay, thank you.
Sure. All right, any questions on that? All right. All right, next, the derivative of the arctangent is 1 over 1 plus u squared times the derivative of u, du dx. All right, so in this one, I'm giving you an application problem. So as a particle moves along the x-axis such that its position is x of t is the inverse tangent of the square root of t for t is greater than or equal to 0. What is the velocity of the particle at t equals 16 seconds? So what's the relationship between the position function and the velocity function?
Velocity is the derivative of the position.
That's it. So what we're going to do here is take the derivative of this and then plug in 16. Okay? So, all right, so here's the formula again. And I'm going to let u be the square root of t, or t to the 1/2. Then du dt, you bring the 1/2 in front, t to the minus 1/2. Okay? So now you plug into the formula, and so the velocity is, okay, so du dx, or du dt, 1/2 t to the minus 1/2 over 1 plus t to the 1/2 squared. All right, now, t to the 1/2 squared, when you multiply those exponents, you just get t. So the denominator is going to just be 1 plus t. All right, then the t to the minus 1/2, you bring that to the denominator using the elevator rule. And then the 1/2, you can just put the 2 in the denominator. So you have 1 over 2 t to the 1/2 times 1 plus t. And so now I plug in 16 for t, and so I get 1 over 2 times the square root of 16, which is 4, times 17. And so then the velocity is going to be 0.007 or 1 over 136. So you take the derivative, then plug in 16. All right, so go ahead and try practice 5A. All right, Chloe, when you've got it.
8 over 257.
There you go. Great job. All right, would anyone like me to go through it? Okay, you guys are making me look good. I appreciate it. All right. All right, next, the derivative of the arc secant. So that is 1 over the absolute value of u times the square root of u squared minus 1 times the derivative. All right, so let's do an example here. All right, so again, here I'm going to let u be 5x to the fourth. So then du dx is 20x cubed. All right, so then I look, here's the formula. So I'm going to apply the formula. So I have du dx, so 20x cubed on the top. And then in the denominator, I'm going to have the absolute value of u, which is 5x to the fourth, times the square root of u squared, so 5x to the fourth squared minus 1. And so now I simplify. Now, whenever your exponent is even, like this, 5x to the fourth, see, it doesn't matter what x is, this has to be positive. So you can drop the absolute value. Now, that's important to know because then you can cancel with the 20x cubed. Okay? And then the 5x to the fourth, when you square that, you get 25x to the eighth. Now, you can't do anything else with the radical, but you can cancel the 20 here with the 5 and the x cubed with the x to the fourth. And so your final answer would be 4 over x times radical 25x to the eighth minus 1. All right? So go ahead and try practice 5b. All right, so Joey, when you've got it.
Okay, I have a question.
Okay?
So if you have, well, so I got to where I have 15x cubed over, and then the absolute value of 5x cubed, and then...
No, wait, it should be 15x squared. That for the derivative.
Oh, okay, yeah, yes.
Okay. So 15x squared over, and then keep talking.
So over the absolute value of 5x cubed, and then the square root of 5x to the 6th minus 1.
Okay. Now, so what can we bring out to simplify here? All right, so 5 is never negative. So you could pull the 5 out of the absolute value. And then you could cancel the 5 with the 15. And then x cubed, what you can do is pull out x squared, because x squared can never be negative. But there's one x that's going to be left over that you don't know if it's positive or negative. So it has to stay in there. Now this is a little bit messy. I hope that doesn't mess you up. Let's see if I can make it.
Mr. Strong,
Yes.
I have a question. So say like the coefficient for like the 5x cubed, say it had been like negative, could you still have taken it out?
No, but you could, but it would just become positive then. So you could think of like the absolute value of -2 times the absolute value of x cubed. And then you could say the absolute value of -2 is just 2. And so you could pull it out, but it would become positive. Okay? All right, thank you for that question. So this is kind of what I'm doing here is, so this can simplify to this. So the 5x squared, then you can cancel with the top, but the absolute value of x, you can't without knowing what x is, you can't take that out. Okay? So, Joey, when you get the final answer, then let me know.
Okay, so 3 over the absolute value of x times the square root of 25x to the 6 over, or minus 1.
That's it. Okay? So, everybody okay with that? Any questions? All right. Okay. All right, so next, the other three. No, that's not that. Okay. So we did the derivative of the inverse sine. Let's see, wait. We did the inverse sine, the inverse tangent, and the inverse secant. Okay. So let's see. What am I doing here? Okay, so we did. So the ones you need to write down are cosine, cotangent, and cosecant. Okay? So the cofunctions. Now, one thing about the cofunctions is that they're all negative. So just like when we take the derivative of just the regular cofunctions, the derivative of cosine, derivative of tangent, and cosecant, they're all negative. So when we do the inverse cofunctions, they're also, the answers are going to be negative. Okay? So I that's why I highlighted the negatives here, just to emphasize that they're all negative. So those are the other three that you need to write down.
Can you scroll down a bit?
Yeah. Okay. All right. So now let me give you another type of application problem where you're going to have to take the derivative. So here it says find the equation of the line tangent to the graph of this. All right. So remember, to find the equation of the line, we need a slope and we need a point. Okay. So to get the slope, we're going to take the derivative. So the slope of the tangent is the derivative here. And so then applying the formula, we get du dx over 1 plus u squared. Okay, and then here the derivative of x is 1. So we just get negative 1 over 1 plus x squared. So now we plug in the given point. See, this is the derivative at any point. So then we're given an x value. And so we plug in 1. And so we get negative 1 over 1 plus negative 1 squared. So negative 1 half. Okay, so that's the slope of the tangent. All right, now we need a point. Well, we've got an x value. How do we get the y value for the point? So we've got the slope. We've got an x value. How do we get the y value?
Plug it into the original equation.
Plug it into the original equation. So then if we plug in -1 here, the inverse cotangent of -1. So what angle has a cotangent of -1? Let's see. So inverse cotangent, that's quadrants 1 and 2. So it would actually be the same angle to add a inverse tangent of -1. Well, except it's in the second quadrant. Well,
Is it 3 pi fourths?
3 pi fourths. Okay. So the point then is -1, 3 pi fourths. The slope is -1/2 from the derivative. So now I put it in the point slope formula from algebra. So I do y minus the y value equals m, -1/2, times x minus the x value. And so that's it. That's the answer. So I had to find the slope by taking the derivative, and then I had to find the point and plug it into the formula. All right, so see if you can do practice 5C. All right, so Aiden, what's the slope of the tangent at that point? So what's our m going to be?
I don't know if this is right, but I got -infinity.
Okay, so, well, it won't be -infinity. I mean, for a limit, that's a good answer. But you got something over 0, right?
Yeah.
Okay, so that's going to be undefined. So in algebra, see, you're thinking calculus, which is good, but we got to step back and think algebra. So what kind of line has an undefined slope? Anybody?
Vertical.
A vertical line. Okay, and what's the equation of the vertical line that passes through x equals 1?
Yeah.
X equals 1.
X equals 1. Okay, very good. So let's just kind of go through it. So when we take the derivative and plug in the point, we get an undefined slope. So that's a vertical line. So the equation of a vertical line is x equals a constant. Well, here the constant that we're given is 1. So the answer is x equals 1. Okay? Any questions on that? All right, well, good job. You didn't get tricked by that one, Aiden. Okay, so next we have integrals evaluated with inverse trig functions. Okay, So when it's going back the other way. So if you have an integral of one of these patterns, or you can put it into one of these patterns, then the answer is going to be inverse sine, inverse tangent, or inverse secant. Now, one thing about these patterns, to put in these patterns, you'll notice that in addition to to finding a U, we also need to find an A. So when we do a U substitution, we'll also figure out what A is as well. And so that's a little different. Okay, we got those? All right, so let's just jump to practice 6A. So which of those three formulas looks the most like that?
The first one.
The first one. So what we do is we say, okay, the A is 1 squared. Okay? So sometimes it's good to write that down. So here, so A is 1, so A squared is 1, and then U is just X. Okay? Well, that's kind of so simple, maybe you don't even need to do it. But let's apply the formula. This is just going to be the inverse sine, and we're going to evaluate it from 0 to 1/2. So remember then, you plug in the top number minus the bottom one. So it's the inverse sine of 1/2 minus the inverse sine of 0. All right, so what angle then has a sine of 1/2? What angle has a sine of 1/2?
Pi sixth.
Pi 6. And what angle has a sine of 0?
0.
0. So then you would do pi 6 minus 0, and so your final answer is pi 6. Now, on a test, remember, if you forget any of this, then when you have a definite integral like this, you can put it in your calculator. Your calculator knows all these inverse trig functions too. And so you could get it, but it's not going to give you the exact answer. So normally the calculator, I would just use it for a check, or if you get stuck. That you're much better off, and it'll actually be quicker if you do it directly. Okay? All right, so go ahead and try B. Practice 6B. All right, so Jordan, when you've got the final answer.
Is the answer pi?
Well, you're pretty close. All right, so first of all, this is which function? This pattern here.
It's the sine.
No, because there's not a radical. There's no square root. So it's inverse tangent. Okay, let's go back. Let me go back to the formulas here. Okay, see, this is the only one that doesn't have a square root in the denominator. So it's going to be inverse tangent. Okay? So this is going to be the inverse tangent, and then you evaluate that from -1 to 1. So you plug in 1, the inverse tangent of 1 minus the inverse tangent of -1. So that gives you pi fourths minus negative pi fourths, or pi halves. So you were half right, or doubly right, or something. Okay? All right, any questions on that? All
Could
right,
you just
go
stay
ahead.
right there for a second?
You bet.
Okay, thank you.
Okay, so if you got that one, then go ahead and start on C.
Okay, thank you.
Sure. All right, Skylar, when you've got it.
I need help. I don't get this one.
Okay, so which of the patterns does this one look like?
The secant one.
The secant. So this is going to be the inverse secant of the absolute value of x, and then the limits of integration are from 2 to 2 divided by radical 3. Okay? So everybody cool with that part? So that's just recognizing which formula to use. All right? So then we plug in the top minus the bottom. Now, what happened to the absolute values here? Where did they go?
They were already positive.
Since they're both positive, we don't need absolute values. So just drop them. Okay? Now, I don't memorize any secants. But what I do memorize is that secant is the reciprocal of the cosine. So the angle that has a secant of 2 over radical 3 has a cosine of radical 3 over 2. And the angle that has a secant of 2 has a cosine of 1/2. So maybe that'll help you, Skylar. See if you can finish it off for me. So, Skylar, you look at the unit circle, you say what angle has the x value of radical 3 over 2?
It's negative pi over 6.
So, well,
It's the answer.
It's at, oh, I see. Okay, so it's pi 6 minus pi thirds. So negative pi 6 is the correct answer. All right. So any questions on any of that? Okay, so really most of the rest of the problems that I thought we were going to be able to finish this, but that's okay. We're going to keep working on it here. But most of them now are just algebraic manipulations of the same thing. So, but there are some tricks, and so we're going to go through more examples. But on 7-7, if you look at that sheet, almost all of the front and half of the back, it's all formulas. Okay? So I would actually like you to write down the formulas before class on Monday from 7-7. So they're all in your book. So just go through, and if you do that, we'll make sure you've got them all. But if you would write down all those formulas, that will save us quite a bit of time on 7-7. Okay, and we'll talk more about it. All right, so what I want to do really here is just kind of show you one little algebra problem that helps us in a trick. So in addition to using the formulas in the tables, you must sometimes remember to use substitution. So that's kind of what I've been doing all along. All right. So the first thing is, well, this one doesn't really require much of an algebra trick, but see, if you think of this like when you have a constant, that's like you're going to use your a for that. A represents some constant. So a squared, if a squared is 9, then a is going to be 3, and then your u is going to be x. So if you think of it in those terms, then you go and you look at your formula sheet and say, okay, which one looks like that, a squared minus u squared underneath the radical? Well, that's inverse sine. So then inverse sine, so it would be x over a, so x divided by 3 plus c. And the other thing is remember, if there's no limits of integration, you need to have a plus c at the end. All right, so go ahead and do D, and then we'll finish it up from there. You could even do that one in your head. All right, Joey, when you've got it.
So just the formula.
Yep.
Okay, so I got 1 over 2 secant to the negative 1 with the absolute value of x over 2 plus c.
Okay. So I got inverse sine. Okay, let's see why it's not inverse secant. Okay. See, if we go back to those formulas, okay, this is where you're comparing it.
Okay, yeah.
See, inverse secant has that extra u right there.
Yeah.
So we didn't have that. So it's going to be inverse sine. Okay? But no, actually, Joey, this is what we're trying to do here, is kind of work out all the little glitches so that you don't make that mistake on a quiz. Okay? So don't worry about that. So then you think, okay, this is 2 squared minus x squared. So it's going to be 1 over, the u is going to be x, and then the 2 is the a. So it's the inverse sine of x over 2 plus c. Okay? Now, but that's fairly straightforward. There are some more algebra tricks in the last column there. So we'll work on that and spend as long as we need to till you guys feel comfortable with it. Okay? So we'll pick it up from there. You're going to write down some formulas for 7-7, and so we'll also be working on there on Monday as well. Okay? All right. Well, that's it for today. Thanks, you guys, for working really hard today. I appreciate it, and we'll see you Monday.